Hi students, welcome once again to my channel, Math Made Easy with PDY. In today's lesson, we are looking at how to divide two polynomial functions, getting the remainder as well as the quotient. In this video, we are going to use the long division approach. Now, our question for today includes number 1, which is find the quotient and remainder if f of x is divisible by p of x. F of x is equal to 2x power 4 minus s cubed minus s squared plus 7x minus 12. And the divisor is p of x is equal to s squared minus 3. In this situation, we cannot use the remainder theorem to determine the remainder as well as the quotient. So we definitely have to use the long division approach. Before you can use the long division approach, you must see to it that the polynomial function has been written in a standard form. What do I mean by it being written in the standard form? You must see to it that the highest power for the variable under discussion reduces until the lowest power of 0. When you analyze f of x, it has the highest power as power 4 and it reduces all the way to the power of 0 term. But for p of x, which is the divisor, it has the highest power of x as 2, but it doesn't have the x to the power 1 term. Therefore, we will replace it with a 0x term. So with the long division approach, we must have our long division sign. Then we have our divisor to be x squared plus 0x then minus 3. Then the dividend is 2x power 4 minus x power 3 minus s squared plus 7x minus 12. In order to divide two polynomial functions using the long division approach, you must use the leading entry to divide. So the leading entry for the divisor is x squared, and the leading entry for the dividend is 2x power 4. So x squared will go into 2x power 4 2s squared times. So we have part of the quotient as 2x squared. We multiply 2s squared by the divisor and we will obtain 2x power 4 plus 0x power 3. Then 2s squared times negative 3 will give us minus 6x power 2. Now we subtract between the two polynomial functions here, and we are going to obtain 2s power 4 minus 2s power 4, which is 0, negative x cubed minus 0 s cubed. That will give us negative x cubed. Negative s squared minus negative 6s squared will lead us to positive 5x squared. Then we can push down the remaining part of the polynomial function, which is 7x and then minus 12. We can still go ahead and divide. The leading entry is s squared, but the leading entry for the new polynomial function is negative s cubed. So s squared will go into negative x cubed, negative x times. Negative x multiplies the whole divisor here, will obtain negative s cubed plus 0x squared, then plus 3x. Then we underline and subtract once again. So we are going to obtain 0 for the first or the leading entry, and 5 minus 0x squared will give us 5x squared. 7x minus 3x will actually give us plus 4x. Then we push down the negative 12. So x squared will go into 5x squared 5 times. So we have plus 5. 5 times the divisor will give us 5x squared. 5 multiplying 0x will give us plus 0x. 5 will multiply negative 3. It will give us negative 15. So now we subtract. Subtracting 5x squared minus 5x squared will give us 0. 4x minus 0x will still give us 4x. And then negative 12 minus negative 15 will end up giving us positive 3. So in this case, you realize that x squared cannot go into 4x, and therefore our remainder is 4x plus 3. Hence, the division between 2x power 4 minus x cubed minus x squared plus 7x minus 12 by x squared minus 3x gives a quotient to be 2x squared minus x plus 5, and the remainder is 4x plus 3. As you know, when you multiply the divisor by the quotient and add on the remainder, it should give you the polynomial function. So per the question, we've been able to deduce the quotient and the remainder when the two polynomial functions divide. Let us move on to the next work example. All the same, you can pause and go over the video. Now, with the second example, we have the dividend as 3x power 4 plus 2x cubed minus x squared minus x minus 6, and the divisor as x squared plus 1. In this situation, the dividend is actually a polynomial function written in its standard form, but when it comes to the divisor, we realize that it's not in its standard form. We still have the x term missing. Hence, with the same way we solve for the example number 1, we are going to introduce a 0x term for the divisor. So still using the long division approach, we will have x squared plus 0x plus 1 to be our divisor, and then the dividend is 3x power 4 plus 2x cubed minus x squared minus x minus 6. So as we said early on, it's always the leading entry that does the division. So x squared will go into 3x power 4 3x squared times. So we have our 3x squared. 3x squared multiplies x power 2 gives us 3x power 4. 3x squared multiplies 0x, it gives us plus 0x cubed. 3x squared multiplies 1, it gives us plus 3x squared. At this moment, we subtract between the two operations. So 3x power 4 minus that gives us 0. 2x cubed minus 0x cubed gives us 2x cubed. Negative x squared minus 3x squared gives us negative 4x squared. Now we push down the remaining entries for the dividend, which is minus x and minus 6. Therefore, x squared will go into 2x cubed, that is 2x squared times 2x times. So we have plus 2x. 2x multiplies x squared, we get 2x cubed. 2x multiplies 0x gives us plus 0x squared. Then 2x multiplies 1 will give us plus 2x. At this moment, we subtract once again, and in subtraction, we'll have 0 for the first term, and then the next term will give us negative 4x squared, and then we'll have minus 3x. Then we push down the minus 6. Now x squared will go into negative 4x squared, negative 4 times. Negative 4 multiplies x squared, that gives us negative 4x squared. Negative 4 multiplying 0 will lead us to plus 0x. Then negative 4 multiplying 1 will give us negative 4. At this moment, we subtract, we'll end up getting 0 for the first term. Negative 3x minus 0x will give us negative 3x. Then negative 6 minus negative 4 will lead us to negative 2. As long as x squared cannot go into negative 3x, therefore we end our division at this moment, which means that per this solution, since the question demanded for the quotient is 3x squared plus 2x minus 4, and the remainder is negative 3x minus 2. As I said, whenever you multiply the quotient by the divisor and add it to the remainder, it should give you the dividend. Thanks so much. I have 2 more work examples, but I would like you to pause and then go through the procedure in using the long division method. The next example, which is example number 3, we have f of x equal to 3x cubed plus 2x minus 4 being divided by 2x squared plus 1. In both polynomial functions, you realize that they are not complete polynomial functions. They are all having missing adducts. They are having missing terms. So since they all have missing terms, we need to make them a complete polynomial function. So we are going to replace those missing terms with 0 and that particular term. So for instance, f of x, to make it a complete or perfect polynomial function, it should be 3x cubed plus 0x squared plus 2x minus 4. And p of x, to make it a perfect or complete polynomial function, it must also be written as 2x squared plus 0x plus 1. Hence, we can go ahead to use the long division method to solve it. So with the long division method, we introduce our long division sign. We have our divisor, which is 2x squared plus 0x plus 1. And in the division sign, we have 3x cubed plus 0x squared plus 2x minus 4. So as we said early on, you always need to use the leading entries for the polynomial functions to divide. So 2x squared will go into 3x cubed how many times? Have you thought of what it will be? It will go in, so it will go in 3 onto x, 3 onto x. If you are not sure of how I had it, this is the way you could have done it. When I mean 2x squared goes into 3x cubed, how many times? This is what it implies. What number will multiply 2x squared? Let's say the number is a variable a, to obtain an answer of 3x cubed. In this case, you need to divide both sides by 2x squared. And in doing so, when you reduce the division, then a will be equal to 3 onto x, all because this x squared can go into x cubed x times, and that is why we had 3 onto x. Moving forward, then it means 3 onto x must multiply 2x squared, and when it does that, we will obtain 3x cubed. Then 3 onto x multiply 0x, that will give us plus 0x squared. Then 3 onto x will multiply 1, that will give us plus 3 onto x. At this moment, we subtract, and when we do subtract, 3x cubed minus 3x cubed will give us 0. 0x squared minus 0x squared will also give us 0. And then now, someone may ask, when 2x subtracts 3 over 2x, what exactly are you obtaining? When you work it out, you are going to obtain half x. Then we push down the minus 4. Someone may ask, how was I able to work it out faster? Now 2x, when you take 3 on 2, it's the same as 1.5x. Therefore, 2 and you taking out 1.5x, it will be left with half x. Then we push down the minus 4. You understand that 2x squared is the leading entry for the divisor, and then half x is the leading entry for what is left, which is a remainder. But 2x squared cannot go into half x, therefore we cannot work out the division. Hence, this implies that per the operation between the division of the polynomial function and then the quadratic function here, our quotient is 3 on 2x and our remainder is half x minus 4. So as I said, the quotient is 3 on 2x and the remainder is half x minus 4. Thank you so much for joining my lesson. It's once again Math Made Easy with PDY. Kindly subscribe to the channel and then share the video for some of your friends to also study. Thank you and have a nice day.